Hello friends, now we will discuss about Werner's theory. Now Werner's theory is very important to understand about the bonding of coordination chemistry. Actually Werner had won first Nobel Prize in inorganic chemistry for his theory. Number 1. In complex compound, every metal has two types of valency. One is called primary valency or ionizable valency, and the second one is secondary or non-ionizable valency. Let us explain it. Let us take an example of this compound. CuNH3 whole 4 SO4. Now this bracket indicate coordination sphere. What is coordination sphere? Coordination sphere is the region where ligand formed coordinate bond with central atom. Here NH3 donate lone pair electron to copper, and 4 such NH3 groups are present, so coordination number of copper is 4, and the oxidation state of copper is 2, and it is satisfied by SO4 2-. So the primary valency is present in the coordination sphere, and it is 4 because copper form 4 coordinate bond with ammonia, and the plus charge of copper is satisfied by SO4 2-. So copper has two type of valency. The primary valency here, primary valency or ionizable valency, which is ionized, is 2, and coordinate bond forms, that is secondary valency, which doesn't ionize, is 4. Therefore, according to Werner's theory, every metal has two types of valency. One is called primary, which is ionizable, and the other is called secondary or non-ionizable. Point number 2. Every metal has a fixed number of secondary valency. Every metal has a fixed number of secondary valency. As for example, iron have secondary valency 6, copper has secondary valency 4, silver has secondary valency 2. So every metal has a fixed number of secondary valency. Number 3. The secondary valencies are oriented in three-dimensional space in a particular fashion. According to VSEPR rule, the secondary valencies are oriented in three-dimensional spaces in such a way that the repulsion between them is minimum. That means the stereochemistry or the particular arrangement of ligands in space, stereochemistry of the compound depends on coordination number, that is number of secondary valencies. If the coordination number or secondary valency is 6, the stereochemistry of the complex is octahedral. If the stereochemistry is if the coordination number is 4, the stereochemistry is either tetrahedral or it is square planar. So, the shape of the complex compound depends on the number of secondary valencies. The primary valency, that is non-ionizable valency, is denoted by dotted line, and the secondary valency is denoted by bold line. As for example, in case of this complex, that is FeNH3 whole 6, SO4, the secondary valency is 6 here and the primary valency is 2. Now, since the secondary valency is 6, the stereochemistry is octahedral. That means the shape of the complex is octahedral. At the central position, iron is present, and at the 6 sides or 6 corners of octahedral, there are 6 ammonia molecules. And only one primary bond is present. Primary valency is satisfied by SO4 2-. It is represented by a dotted line. Here the positive charge of iron is +2. So the secondary valencies are denoted by bold line and the primary valency, which is satisfied by SO4 2-, is represented by dotted line. This is all about Werner's theory. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.